Welcome viewers to part 7 of the TitanBot series. In this episode we are modeling the forward accessory deck. This deck sits between the gearboxes at the front of the TitanBot. We'll be attaching a gripper to the top of this deck in the future, and we will also use it for attaching a camera so that we can use AI vision in a future iteration of this robot. This part is modeled after the pattern that we created for the Vetronics deck. So it's got a conduit through the trunk, and we've included wire access holes through the side of the trunk for any wiring that we want to bring up to the top of this accessory deck. So let's get started. Begin by creating a body and a sketch. We'll create the sketch on the XY plane and grab the polyline tool, and we're going to create a simple shape that's going to outline the edge of our deck here. We're going to make the deck symmetric with respect to the x-axis, and let's set the overall width of the deck, it's our vertical height with respect to our current view, to 94 millimeters. We are going to make the top of the deck symmetric with respect to the y-axis, and we're going to make sure that the two edges of the deck are equal to each other. Next, we're going to model out the relief that will accommodate the ultrasonic sensor. So again, with the polyline tool, this is one of the main differences between the accessory deck and the Vetronics deck. This relief is so that the ultrasonic sensor doesn't stand out from the front of the vehicle. So we've constrained those so that they're both vertical. We're going to make it symmetric with respect to the y-axis, or sorry, the x-axis. So both of those are the same width. We'll make it, we will set the overall width of this, the depth of the relief. We'll set that to 5.7 millimeters. And now we're going to set the distance away from the back of the deck. So we're going to do that by left-clicking these two vertices. And we'll set the distance here to 60.8 millimeters. Now the next thing that we're going to do is we're going to add the two arcs that define the edge of our deck. We're going to use the Create Arc by Center tool. We're going to start by left-clicking on the x-axis. We will click on the end of the top part of the deck, and we will left-click on the end of that relief. And we will do the same for the bottom part of our shape, making sure that we click on those endpoints. And now all we have to do is, well, we need to constrain, let's constrain this to 48.2 millimeters. Now we can constrain this arc. So there we go, 302 millimeters. We'll just bring that back into view. So there we are. So we've now got our fully constrained shape, and we can close out of the Sketcher workbench. We're going to pad this shape out to 3 millimeters. And we're going to add the trunk to the top of this shape. So create a sketch on the top of it. And we're going to reference the back of the deck here. And we're going to use the rectangle tool. And we're going to create the outline of the trunk. We're going to make sure that it is symmetric with respect to the x-axis. And now we're going to set the length of the trunk. Trunk is going to be set to 60.3 millimeters. The half millimeter clearance on the front here accommodates some surface mounted components on the circuit board for the ultrasonic sensor. We're going to set the width of the trunk to 24 millimeters, and that fully constrains the trunk, so we can close out of this sketch. And we're going to pad this to 27 millimeters. Next thing that we're going to do is we're going to add some mounting points that will attach the trunk to our mobility base. Going to grab the circle tool, and we're going to create two circles that are coincident with the x-axis. Set both circles so that they have an equal diameter, and we will set that diameter to 2.8 millimeters. We're going to set the distance between our two mounting points to 40 millimeters, and then we're going to offset these holes from the edge of the deck by 10.3 millimeters. And so now that our mounting holes are fully constrained, we can close out of that, and we're going to pocket those to 12 millimeters. All right, so the next thing that we're going to do is we're going to create that conduit through the length of the trunk here. So here we're going to create a slot. And this slot is going to have an overall length. Looks like the slot needs to be overly constrained. There we go. So just move the slot a little bit and that will fix that problem. So we're going to select the midpoints of both ends of the slot and we'll set that to 6 millimeters. We're going to set the diameter of the slot, or sorry, the radius of the slot to 6.5 millimeters. And we're going to reference the bottom of the trunk, and we will make it so that this conduit sits 11 millimeters away from the bottom of the trunk. All right, so that shape is fully constrained, and so we can close out of the Sketcher workbench. And we're going to pocket that all the way through the trunk. So a pocket length of 61 millimeters clears the trunk. And now we're going to add those access holes on the side of the trunk. We're going to begin by creating 3 circles. Make sure that you don't click right on the y-axis for that third circle because it will be constrained coincident with the y-axis and that will make it awkward for you. We're going to grab the external geometry tool and we're going to reference the 2 outer edges of the trunk. And now we're going to switch over to our construction geometry and we're going to create a line that we connect from the edge to the center of our 2 outside circles. We're going to make sure that both of these construction lines are constrained horizontally. And we're going to make sure that these 2 construction lines are of equal length to each other. Now we're going to add 2 more construction lines between the outer circles and our inside circle. And we need to constrain just one of these to the horizontal. And we're going to take these 2 new construction lines and we're going to make them equal to each other. Now we're going to take these 3 circles and make sure they have equal diameters, and we're going to constrain the diameter of our circle to 14 millimeters. Last thing that we're going to do is we're going to set the distance between 2 of these circles to be 18 millimeters. And with that, our circles are fully constrained, so we can close out of the Sketcher workbench, and we're going to pocket these circles to a depth of 24 millimeters to clear them through the trunk. Okay, now we're going to move back over to the top of the deck. We need to add a relief for the signal wire that runs the ultrasonic sensor. So we're going to add a sketch to the top of the deck, and we're going to zoom on that relief. We need to reference the inside edge of the relief, and we're going to use the polyline tool. We're going to create an initial shape that looks somewhat like this. Okay, so we've got, oh, and we need to close that shape as well, so make sure you do that. Okay, we've got one line here that we need to constrain horizontally, and now we can make it so that this shape is symmetric with respect to the x-axis. So we'll do that for the both edges here. All right, so both edges are constrained symmetric to the x-axis. Now we're going to set the lengths of these inside shapes. We need to make sure that these two sides are equal to each other. Now we'll make it so that we have two edges to constrain now. So, well, 4 technically. So let's constrain this one to 4.8 millimeters. And we're going to set the next one to, there we go. We'll set this one to 4.5 millimeters. Now we're going to set the overall width, or the height with respect to our current vertical. 11 millimeters for that. And we'll set this one to 5 millimeters. All right, so these reliefs create the necessary space for the wires to move behind the ultrasonic sensor when it's attached. Let's close out of the Sketcher workbench, and we're going to pocket this shape to 10 millimeters. That'll clear all the way through down to the conduit that we created through the trunk. And the next thing that we're going to do is we're just going to add a couple of wire access slots on the top. So when we're adding things to this accessory deck in the future, we've got some pass-through points for some wires. So we're just going to create 2 rectangular slots. We're going to make it so that these slots are symmetric with respect to the x-axis. We're going to make them of equal length to each other and of equal width to each other. And now we're going to constrain the size of this. So that length is going to be 35 millimeters. That width is going to be 4 millimeters. We're going to set a distance between these slots of 45 millimeters. And we're also going to make sure that these slots are symmetric with respect to the x-axis. And with that, these slots are fully constrained, so we're going to pocket them through the top of the deck. And we're going to move on now to creating some shell hardpoints on the bottom of the deck. This will be where the front fenders connect in order to create additional rigidity to our shell. Going to reference the 2 outer edges of the deck, and we're just going to grab the rectangle tool, and we're going to create 2 rectangles that are coincident with the edge of the deck. And we will make it so that these 2 shapes are coincident. Oh, looks like I clicked off there. So with those 2 vertices, the x-axis, or the x-axis is selected. Let's see if I selected those in the right order. Very good. Okay, so those are now symmetric with respect to the x-axis. So let's constrain the width of these to 10 millimeters. And let's constrain the overall height with respect to our vertical. That's 3 millimeters. All right, so both of those are fully constrained, so we can close out of the Sketcher workbench. And we're going to pad those out to a height of 5 millimeters. And then we're going to add the anchor holes here. So create a sketch on one of those. And we'll create a circle here. We're going to reference the bottom of this mount. We'll set the diameter of our mount hole to 2.8 millimeters. We will set the hole so its center is 3 millimeters away from the bottom of our mount point, and we're going to put it right in the middle of our mount point here. So we'll set that to 5 millimeters. All right, so this mount hole is now fully constrained. We can close out of this and pocket that hole. And we're going to repeat that process for our other mount point here. So we'll add another circle. We'll reference the bottom of the mount. We'll set the diameter to 2.8 millimeters. We will set the distance of the center of the circle from the bottom of the mount 3 millimeters, and we will position it right in the center of our mount by setting this to 5 millimeters. All right, so we'll close out, we'll pocket that, and now we have created a our front deck. There we are. And now we can mount that on the front, and our next videos we will start building the shell for the robot. This shell is going to be inspired by a Humvee design, and all of the parts of the shell will be planar to make sure that it's easy to 3D print these.